The formation of mountains is a complex geological process involving the movement and interaction of Earth's tectonic plates. This process, known as orogeny, is driven by plate tectonics, the theory that explains the movement of large plates that make up Earth's lithosphere. The science behind the formation of mountains encompasses geology, geophysics, and tectonics, offering insights into how these majestic landforms are created and shaped over millions of years. Mountains primarily form through three main tectonic processes: convergent boundaries, divergent boundaries, and transform boundaries. Convergent boundaries, where two tectonic plates collide, are the most common sites for mountain formation. When a continental plate collides with another continental plate, the crust is pushed upward, creating mountain ranges. The Himalayas, for example, formed from the collision between the Indian plate and the Eurasian plate, which continues to push these mountains higher. Subduction zones, a type of convergent boundary, also play a critical role in mountain formation. In these zones, an oceanic plate is forced beneath a continental plate or another oceanic plate. As the subducting plate sinks into the mantle, it melts and creates magma, which can rise to form volcanic mountain ranges. The Andes Mountains in South America are an example of mountains formed by the subduction of the Nazca Plate beneath the South American plate. Divergent boundaries, where tectonic plates move apart, can also lead to mountain formation, though this is less common. As plates separate, magma rises from the mantle to fill the gap, creating new crust. This process can result in the formation of mid-ocean ridges and volcanic mountains. The Mid-Atlantic Ridge, for instance, is a divergent boundary where new oceanic crust is formed, leading to underwater mountain ranges. Transform boundaries, where plates slide past each other, generally do not create mountains, but the intense pressure and friction can cause significant deformation of the Earth's crust. This can lead to the formation of fault block mountains. The San Andreas Fault in California is an example of a transform boundary, where the Pacific Plate and the North American Plate grind past each other, causing earthquakes and, in some cases, uplifting the land to form mountains. Another important factor in mountain formation is isostasy, the concept that Earth's crust is in gravitational balance. When large amounts of crust are added, such as through volcanic activity or the collision of tectonic plates, the crust sinks deeper into the mantle to maintain equilibrium. Conversely, when erosion removes material from mountain ranges, the crust can rebound and rise. This balancing act contributes to the long-term evolution and stability of mountain ranges. Erosion and weathering also play crucial roles in shaping mountains. Once mountains are formed, they are subjected to the forces of wind, water, and ice, which gradually wear down the rock. Rivers carve valleys, glaciers scour the landscape, and weathering breaks down rocks into smaller particles. These processes create the diverse and often dramatic landscapes seen in mountainous regions, such as sharp peaks, deep valleys, and rugged terrain. The rock cycle is integral to the formation and transformation of mountains. Sedimentary rocks formed from eroded material can be buried and subjected to heat and pressure, transforming into metamorphic rocks. These rocks can then be uplifted to form mountains. Additionally, igneous rocks, formed from cooled magma, can be uplifted and exposed through tectonic activity, contributing to the composition of mountain ranges. Geophysical studies, such as seismic tomography and satellite imaging, have provided valuable insights into the structure and dynamics of Earth's crust and mantle. These technologies allow scientists to observe the movements of tectonic plates, the distribution of stress and strain in the crust, and the processes occurring deep within the Earth. This information is crucial for understanding the mechanisms of mountain formation and predicting geological activity. In summary, the science behind the formation of mountains involves the interplay of tectonic plate movements, isostasy, erosion, and the rock cycle. Through processes such as plate collisions, subduction, and volcanic activity, mountains are formed and continually reshaped. Advances in geophysical research enhance our understanding of these dynamic processes, revealing the intricate and powerful forces that create the towering peaks and expansive ranges that define Earth's landscape.